So,
Yes, I'm listening.
if we're making substitutions to the original solution that was given, is it proper form to write y prime prime, or do you want us to write it in the same notation as in the original
Oh my
solution?
goodness, I would care less.
You care less?
I just imagine you guys understand these are synonymous anyways.
Okay.
Completely irrelevant. By the way, you guys, that was just my scratch paper. For me to answer this question, I want to show you, the reader, that if I start off with the left-hand side, that is to say, if I start off taking a peek at the second derivative for y with respect to t plus omega squared times y,
I have no idea.
I want to show you that eventually I'm just going to get 0. And if I can bridge that gap, I've proven what I wanted to show. Let's just do it. Now with my scratcher, I got to confess, I've already computed the second derivative. That is that a negative omega squared? Yeah. C1 cosine of omega t minus omega squared C2 sine of omega t plus omega squared times, well, whatever the heck y was. Wasn't that C1 cosine of omega t plus C2 sine of omega t? Or shall I say, what is sitting in front of me is actually not that, but negative omega squared. C1 cosine of omega t minus omega squared times C2 sine of omega t. I'm wasting our time, aren't I? Because technically speaking, I'm just going to remove parentheses with the last two terms and check this out. Not only do I have some like terms I can collect, I also have that the pairs of these are additive inverses. Ah, shoot. I'm done. That equals 0. Piece of cake, isn't it?
Yeah. So say we got that part, but we didn't get the amplitude of motion part.
You might get as many as 5 points.
That's fine.
So the second part, and show that the amplitude of the motion is, would you guys just take a peek at the sinusoidal wave? What's its amplitude? Why are you stalling? Why are you stalling? You should stall. I think you're stalling because I don't have a single sine or cosine function there. If I did, piece of cake, just look at the coefficient and you're in business, you've got the amplitude. Agreed? Alright, so I'm stalling too. I guess when I take a peek at it, it's the sum of two trig functions. At a glance, maybe you can't identify what the amplitude is. Can I erase this? Yeah. However, given that I got a sum of two terms, there's addition. Oh shoot. If I can think of these in terms of sines and or cosines, that'd be kind of slick. So if you don't mind, let me draw a nifty little picture. Let me consider an arbitrary angle, I'll call it phi. And suppose in this case I label these sides, I don't know how you want to do this. I think this doesn't really matter. How about C1 and C2? What's the length of the hypotenuse?
Square root of C1 squared plus
Now don't you guys agree when I look at the y being equal to C1 cosine of omega t, you guys, am I writing down the right subscripts and functions? So I have to look back. Is that correct?
Yes.
However, if I force the denominator for C1 to be, whoops, I said, force the denominator of that fraction to be, well, this mess. I think this is starting to look nice and recognizable. You guys okay with this so far? I asked, are you guys okay with this so far?
No,
No, why not?
because I don't know how you were just able to force the denominator to equal that.
You're right. I just committed a grave math B sin. I have to fix it.
After you do that, can you explain how you set up your angle phi?
Absolutely. But you guys, first things first, I think I made a mistake. I took whatever I had on the right-hand side, divided by the square root of garbage. I'll compensate. I'll multiply by that as well, so that in the end, all I've really done, you guys, is multiply by a funky-looking form of 1. It's just that now I've got the square root of C1 squared plus C2 squared times, let's play. Look at that picture. What the heck is another name for this ratio?
Cosine.
Cosine of what?
B.
Times the cosine of omega t. Plus, oh look at that, that's just times the sine of omega t. By the way, what you see in my parentheses is nothing more than the result of applying in the backwards fashion Look at that, the subtraction angle identity for the cosine function. I guess that just simply gives me the cosine of omega t, whoops, I misspoke. I meant phi minus omega t. If you prefer to write it the other way around, I guess it's the square root of c1 squared plus c2 squared times the cosine of omega t minus phi. Oh shoot, wait a minute, I just made a mistake. Is this the same as this instead of parentheses? No, it's not. What is the cosine of this? The same as cosine of that. Yeah, because the cosine function is. Yeah, because the cosine function is
Reflected against the x-axis.
well, it's a consequence of the fact that the cosine is a even function. Yes, I agree. I agree. Oh, by the way, now there's only a single cosine or sine function sitting here. The amplitude is sitting right out front. It's just the square root of that mess. You guys happy? Sir, you asked me how the heck did I create the triangle? I forced the issue. I was saying to myself, I really just want a single sine or cosine beast. I see a sum, so let's force the issue of being able to evoke my addition, or in this case, excuse me, subtraction angle identity for the cosine function. But that being the case, I thought of this as cosine of something, but it's not necessarily less than 1. So I combined it with C2 and computed that hypothesis.
So you conjured a triangle just for, just to help you.
Just exploit the subtraction angle identity for the cosine function.
Did
How do
you?
get rid of the subtraction? Cosine.
You mean, how do I get rid of this subtraction?
Well, I mean, the answer is only the square root of the triangle.
Oh, I see, I see. You know what I just did? I showed you a different way of representing y, but now that this is another name for y, it's a sinusoidal wave whose amplitude is the coefficient. So the amplitude is just what's inside that box, because it's outside the cosine function.
So, did you actually lift that from the homework? 'Cause I don't remember that part in the homework.
Did I grab the wrong section?
It's in 1-1.
Oh, it's number 8.
It is? All right.
As a matter of fact, last night when I typed this up, I'll give up. I just opened your book and I typed the same darn thing in. I may rephrase some of the words, but all the letters and the functions are identical.
What I did was I just found where dy dx equals 0. And when you find that point, you find where what t equals when the derivative is 0.
But how would that help you come up with the amplitude?
Well, the amplitude is is y of that t.
Right, where your derivative is equal to 0. Got it. I like
Oh.
that. That's an alternative. I'll buy that. Anybody else? How many of you do you think answered this question correctly? One,
Half of it.
two and a half. I'm gonna have a long weekend.
We get a take-home quiz, right?
Yeah, okay. You guys pay for this?
Yeah, sure. That's cool.
You know, last night, I gave my first Math 31 quiz, and when I finished, they went to go over it, and I went over it, not one person answered it correctly. It was so demoralizing.
What was it?
It was this simple. It's one where you're supposed to look at it and write down the answers. There's no work. And you guys tell me, be honest, isn't this straightforward?
Oh, right now it's very
Could you guys give me the answer?
That's just what you said.
Yeah.
No, you sub works just fine. But can you give me the answer?
After writing it out and solving it, I
No, just looking at it.
Oh, man.
Anybody, please?
That looks like a sign. Looks like a sign hyperbolic. X plus.
Inverse. Yes, no?
No.
If you don't see it, don't listen to me. Just let you be that thing, you're done. Hey, you sub.
Yeah.
All right, I'll leave you alone. So you guys, you got practice last night with separation of variables?